My name is Mingze. I'm a research scientist with CSIRO, the Australian National Research Agency. Today, I'm going to talk about how we use smart glasses to support situated decision making in an aquaculture setup. In the rest of the talk, we briefly describe the operational challenges in prawn farming and how we use the practical guide to choose smart eyewear for a new proposed pond visualization system. Then we describe our on-farm trials and the results, and more importantly, we'll focus on the lessons we learned and how that can help others in the future. The work I'm talking about today was part of a much larger project called Digiscape Precision Aquaculture. Overall, that project was looking at using smart glasses to allow farmers to make better decisions, which will ultimately allow them to produce more prawns. Then we wanted to understand how the water quality management works, because that, according to farmers, were the most important things. Then we talked to farmers, shadowed them, a lot of interviews. We found that these are the main steps. They first will collect the data using handheld sensing units, for example, the one shown in the picture. Then they will analyze data using Excel and look at the plots and the visualizations, and then decide two critical tasks. One is adjusting the aerators or aeration control task, and the second one is to adjust the water exchange by turning on and off the water pumps. Then you would think that farmers have been doing this for years. They have tons of historical data. When they go in the pond, they will have the current reading. Then they should make a decision. However, that isn't the case because there's no way for them to access the plots in the field. And that ended up with a delayed decision because they need to travel back to the office, do the analysis, make some notes about the changes, then they travel back to the field. And then we thought, how about we let you wear smart glasses that's able to pull historical data and also read your current reading and gives you the plot. Then you will be able to make decisions. This was strongly validated by the farmers during brainstorming or early design stage. The first challenge we had was which device we should use. If you were doing this in an indoor environment, probably any smart glasses will do. However, we are using this in an outdoor environment in a farm that's built in the coastal area. It has extremely high level of humidity and salinity. And we talked to the farmers to understand what we need to consider. They said, these are the things you need to consider, which are in the paper. Please read that. And then we came up with a list of criteria: ruggedization, weight are the two most important things. Because if the device is not ruggedized to some degree, it will break quite easily, probably every 3 months. Then the weight allows you to wear that for hours instead of minutes. We ended up using Google Glass Enterprise Edition 2 at the time this study was conducted. But new devices came out every day, and the criteria will guide you to select the best one for your project. Having decided which device to use, we next want to understand how farmers visualize their data currently. And this is what you see is actually being used in a commercial farm. It's an Excel visualization with multiple parameters. You see the plots, which is nice. However, anyone has used smart glasses, you will know that it's impossible to do this with the smart glasses because you simply can't see and read anything. In order to design the new visualization that will fit smart glasses, we use the user-centered design approach. We talked to the farmers several rounds of time. We came up with multiple designs, and this is what we end up with. In this particular example, we did not use any machine learning model there. If you want, you can insert a machine learning model and then give you the forecast. But for this plot, you will see the optimal range of this parameter, and if any value is outside that optimal range, then that allows them to make better decisions. After that, we conducted the on-farm trial with 5 farmers. We ask them to examine the visualization for 50 ponds, and for each pond they need to decide whether they want to adjust the aeration or adjust the water pump. We got the ground truth from the farm manager, who used the conventional tool, sit in front of computers, spend a good amount of time, and made sure that decisions were confident and sound. We also collected task completion time to see how fast or slow this compared to conventional way. The results were quite promising. For the aeration task, we had 89% accuracy and extremely low standard deviation, only about 2%. The same thing for the water exchange task, 86% accuracy and 3.5% standard deviation. That means the farmers were able to make consistent decisions and good decisions during the trial. We also found that task completion time was pretty good, and the main TCT was about 7.5 minutes, and we did see a bit of a standard deviation here, and we found that younger generations was able to blast through the process. However, some people did struggle with the small display and some fitting issue, and spent a bit of time, about 10 minutes. That includes the time they spent adjusting the device, etc. But even though taking that into consideration, it is still at least 40% faster than the conventional way, which is like 20 minutes at least, sometimes 30 minutes. And let alone, it also brings other benefits like electricity saving, labor saving, reduced carbon footprint. The top 3 lessons we learned from the on-farm trials. Firstly, simple static visualizations are enough for this kind of tasks. And also, it is quite impossible to do interactive visualization on this type of smart glasses because the users could not select things accurately, like using a mouse. On-farm studies also need to be highly flexible and interruption resistant. This is unlike a lab-based study where you can have the participants, like say 30 minutes and uninterrupted. Whereas in a real-world scenario, farm is a very dynamic environment. Emergencies, unexpected things happen all the time. When that happens, the farmers need to go, and your session will be interrupted. So that has to be designed and loosely coupled in nonlinear manner. We also found that you need to provide really, really clear and concise information and instruction for the farmers to learn how to use the device, especially when you're running this remotely. The on-farm trial has strongly demonstrated that smart glasses has great potential in supporting farmers to make efficient and informed decisions. However, there are things that we need to consider before deploying this to a fully production environment. For example, the first thing to consider is automatic pond localization. In our study, we prescribed the order of the ponds the farmer will go through. They will start from pond number 1, number 2, until number 50. However, this isn't the case in the real-world scenario. We need a mechanism to let the device automatically figure out where it is. And this will save farmers from manually entering their pond location. The second thing we found was farmers told us they prefer voice command because they have their both hands occupied. But we found that at least all the speech recognition engine that we tried on device, Google Cloud, Microphone Azure, and others, all of them suffered from strong wind noise and very, very noisy machine, like those water paddlers running in the background. And there's another thing to tackle. And we're interested in seeing, maybe today, there are waterproof, rust-resistant, optical see-through augmented reality headsets. They might be able to provide more interesting capabilities, and we'll be interested in seeing how that looks and how that will work. On the right side is an updated device that we kind of current version of it. And then here comes the end of my presentation. Thanks for listening.